Last time we learned, you know, if you take a lot of samples out of a population with the big enough size, and you will find out the sample mean, the distribution of the sample mean is normal distribution, and therefore we can find out using z-table to convert this normal distribution into the standard normal distribution, and then using the z-values we can find out the probability of the population mean falling into the certain range. Okay, this time we continue the same chapter, not the same chapter, the same PowerPoint slides, but in different chapter, chapter 9. Point and interval estimates. A point estimate is a single value derived from a sample and used to estimate a population value. Again, when the population is a huge or big group of the data, it's very impossible for us to find out the features of the population. We try to use a sample to know about the population. So point estimate is actually we use the sample statistic to estimate the population values. Second, a confidence interval estimate is a range of values constructed from sample data so that the population parameter is likely to occur within that range at a specified probability. The specified probability is called the level of confidence. Okay, the formula for the confidence intervals. Confidence interval for population mean is sigma known. So if we plot out a range for population mean with population standard deviation is known, we use this formula. X bar plus or minus and minus z value times sigma over square root of n. So X bar is the sample mean. Z is the z value for a particular confidence level. So usually the confidence level is given information. Sigma is the population standard deviation. N is the number of observations in the sample. If the sigma is not known, means if we do not know the population standard deviation, we might know the sample standard deviation, then we will not use the z value here. We're going to use a t value, but the t value, from the t distributions, will not required in this course. Okay, so you're gonna know if you want to use this formula to find out the confidence interval for the population mean, we're gonna use the z value here. Then when we use the z value, means the sigma population standard deviation is known. Okay, first thing we should know about this formula: the width of the interval is determined by the level of the confidence and the size of the standard error of the mean. Second, standard error is affected by two values: standard deviation, number of observations in the sample. So this part is actually the standard error of the standard error. So let's take the example. The American Management Association wishes to have information on the mean income of medium managers in the retail industry. A random sample of 256 managers reveals a sample mean of 45,420. The standard deviation of this population is 2050. The association would like answers to the following questions. First, what is the population mean? Second, what is the reasonable range of values for the population mean? Third, what do these results mean? So from this question, there are some given informations. Let's check that again. First, sample number is 256. So that means n is 256. Second, sample mean is 45,420. So that is x bar. X bar is 45,420. Standard deviation of the population is 2050. So sigma is 2050. Okay, for the first question, what is the population mean? In this case, we do not know. We do know the sample mean is 45,420. Therefore, our best estimate of the unknown population value is the corresponding sample statistic. Remember, try to recall what is sample statistic is the features about the sample. For example, sample mean is sample statistic. Sample standard deviation is sample statistic. So if we do not know the population parameters, we can use the corresponding sample statistic to estimate the population parameters. So here the answer for the first question is the sample mean of 45,420 is a point estimate of the unknown population mean. Second question, what is the reasonable range of values for the population mean? Suppose the association decides to use a 95% level of confidence. Okay, to find out under certain percent of the confidence level, we want to find out the range, the range that the population mean might fall into. We use the formula x bar minus and plus z value times sigma over square root of n. So here equal to 45,420 plus and minus 1.96 times 2050 over sigma root square root 256. This number we already know is sample mean, that's x bar, and this number is the population mean, sigma, and this number is the number of the sample size. Here the 1.96 is the z value. The z value, for the 95% level of confidence. So for 95% of level of confidence, how can we find out the z value is 1.96? Remember, in the normal probability distribution, this 95%, when we try to find the z value, the 95% is the half of it is 47.5%, right? So the half of it is actually the 0.475. So we go to the z table to find out the 0.475 is here. You find out the 0.475. That is the half of the 95%. So once we find this number, go horizontally to the first column, that's 1.9. Then from the 0.475, go vertically until the first row is 0.06. So that means the corresponding z value to the 0.475 is 1.96. Okay, so let's go back to the slides. That's how we find out the z-value for the 95% level of the confidence is 1.96. So the result of that is 45,420 plus minus 251. So the population mean gonna follow into this range at the 95% level of the confidence. So here we call this 45,169 and 45,671, the two number from this formula, we call that confidence limit. And this plus and minus 251 is referred to as the margin of the error. So how do we explain this? Check the next slide. So what do these results mean? What is the interpretation of the confidence limits 45,169 and 45,671? If we select many samples of the 256 managers, and for each sample we compute the mean number and then construct a 95% confidence interval, we could expect about 95% of these confidence intervals to contain the population mean. Conversely, about 5% of the intervals would not contain the population mean, annual income, the population mean. That's the explanation to the result. So for this sample, means 95% probabilities that the population mean follow into this range, and 5% probability population mean is not in this range between 45,169 and 45,671. Okay, so in the following slides introduce how we apply the t-distribution, another distribution just similar to the z-distribution, just we need to use that in a different situation. But as I said, it will not be covered in this course. Okay, so but I'm gonna use this slide to explain to you how do I find the z-value for the 95 confidence level. So as I said, when we talk about the 95% confidence level, so this half, for the normal distribution, right? Normal distribution is symmetrical. So the two halves are identical. And this half, identical is one thing. Second is the area under this normal distribution curve is 1. What that means the probability is 100% is 1. So this half is 50% or 0.5. So if we want to find the z-value, we want to find the z-value for this point, we need to find out the area for this part. This part is 0.95 divided by 2. That's 0.475. So that's why we go to the z-table to find the 0.475. Then that's how we found out the 1.9. Show it graphically is here. So this part is 0.475. So we get the 1.96 z-value for this. And these two shaded area, the two tails, each is 0.025. Okay, 0.025. Together is 5%. Together is 5%. So if we want to find the 95% confidence level, that's how we found the z-value. For the formula, we use x bar minus and the plus the z times the sigma over square root of n. If the confidence level is 99%, what does that mean? 99% means this half gonna be the 0.99 divided by 2. Okay, what that means this half gonna be the 0.49. Okay, 0.49. Then we go to the z table, find out the 0.49, then find out the corresponding z value for these 2 points. If the confidence level is 99%, that means these two tails together is 1%. Okay, so hopefully you know how to find out the z value, under the given confidence level. Okay, this is all for this week. So hopefully you understand how to find out the probability. Not the probability. How do you find out the range? The confidence limit for the population mean to fall in under the certain probability, certain confidence level. Okay, if you have any questions, please send me email, or please send me email, then we can set up the online office hour.